this one will be plus minus q a over r, and this one will be r square plus a4 by r square plus 2r a square over r and cos of the angle, and this one is 1 over 2 plus q a over r, and the only difference between these two will be just minus here. So r square plus a4 over r square minus 2r a square over r cos of the angle. Right? Now we will have to apply our limits, these limits. So, in the case we will consider a uniform electric field, then this R is supposed to be too huge. And we say that this R, this is our observation point R, this R compared to the actual distance R of the charges is such that this small r will be much less than this r, because our observation point should be somewhere close to the sphere, because the sphere should be in a uniform field, like where the lines are actually flat, and this r will be much away in order to not consider the curvature of the field lines. So for this situation, what we will do, we will put here and expand this one, and similarly we will expand this one as well, and like the others. So let me take one value of this. Let's take first this one. So I can write that r square plus 2rr cos of theta, and the power will be minus half. If this one will come up, then it will be minus half. Let's take r square is common, because I want to have r over r. So what it will be? I can write that when r square will be taken common, then 2 will cancel, and I will have r power minus 1 remaining here. And here I can write, this will become 1, this will become r square over r square. So I can write that r minus 1 plus r square over r square plus, when this one will be divided by r square, then 1r will cancel with one of the r, so it will be 2r over r plus 2r over r and cos of the angle, and the power will be minus half. Okay, so after this, you know about the relation that f1 plus x raised to the power n, this is approximately 1 plus nx. Fx will be much less than 1. So I can apply this relation, and now I can write that only minus 1 over 2 will be multiplied with this. Okay? So this will be equal to r minus 1 and 1 minus 2. So this is, the power is minus 1 over 2. So r square over 2r square, and then minus 2 will cancel, and we will have minus r over r and cos of the angle and some other terms. some other terms, because here I have written equality, I am not approximating this thing. So plus some other terms will be there, and this will be your relation. Similarly, if I take one relation from here, then this will be r square plus a 4r square plus 2 and r a square over r cos of the angle minus 1/2. And here I take small r is common. Okay? Because you know here that now this is not coming into the ratio. So I will take small r is common now. So this will be equal to r minus 1. Because our square is taken as common, so square cancel here, and we will have r minus 1. And then here I will have 1. And then plus, what about this one? It will be a4 over r square r. a4 divided by r square plus, what about this one? 1r square will cancel with this, so we will have plus 2 a square over r plus 2 a square over r and cos of the angle minus half. So this is equal to r minus 1 and 1. Now I will apply this formula, this relation. So it will be 1 minus half this one. So 1 minus a4 divided by 2r square minus 2 will cancel. So a square over r and cos of the angle plus some other terms. Right? It's clear up to here? Yes. Just some mathematical steps. Only we are writing the mathematics in brief. So now put all these values. So I will have that the relation will be equal to 1 over k pi of r. So 1 over k phi of r is equal. First put those values. Okay. Now I can write that over here we will have to specify one is over this limit, which is r will be less than r. What about the comparison of a with r, small r? A with small r. A is the radius of the sphere. Small r is the observation point. So the observation point is always greater than the radius of the sphere. So we will have to take that into account as well. And this is the reason that since A over R and A over R are less than 1. Right? A over R will also be less than 1 and A over R will also be less than 1. They cannot be 1 or greater than 1. So I can write now what will be over here. This one I solved here. And this is equal to Q. And now this one I can write 1 over R. So this will become Q by R. So I have to take Q by R. And then the remaining term. What is the remaining term? The remaining term is this one. And this is equal to 1 minus R square over 2R square minus R over R cos of the angle plus some other terms. And then plus, and we have minus Q over R. Because now what will happen here, if I expand this one, the only difference that will occur will be 1 minus and here will be plus, right? Because here I am having minus. So the next term will be minus Q over R and 1 minus R square over 2R square plus R over R cos of the angle and some other terms. Clear? Similarly, what about this one? This will become minus QA R and R minus 1 will come under this one. So minus Q A R and 1 over R from here because R minus 1, so it will be R here. And then the rest of the relation, which is equal to 1 minus A4 over 2R square and minus A square over R cos of the angle, and then this will become, as this was minus, the next term is plus. So plus Q A over R, and here you will have to write the difference again. A4 over 2R square, and this will become plus. Because in the next one we are having minus here, so this will become plus, and this will be A square over R cos of theta plus extra terms. And now we can combine them. So this is equal to Q over R I can take as common. Okay, if you take Q over R as common, then what's remaining? Cancellations directly so that it will save us some time. Q over R is common, this is 1 and this one is minus 1. So these two are actually cancelling. This one is minus R square over 2R square and minus minus become plus, so they are cancelled. And then this one is minus R over R cos theta and this one is minus R over R cos theta. So they are added, right? So I will have minus 2 minus 2R cos theta divided by R. Okay, and there will be some extra terms as well. I cannot ignore them. And plus this one is, I am writing plus 2QA. If I take plus QA over RR, so this one is common, is plus QA RR. I have taken the plus QAR as common. Then this one will be cancelling with this one. A4 is minus, it will be cancelling with this one. These two will be added because this minus and this minus will become plus and this is already plus, so they will be added, and this will be 2a squared cos of theta divided by r plus some other terms. Clear? Now we will have this thing equal to minus 2qr. Okay, this is finally minus 2q r over r squared cos of theta plus 2qa over r and q squared over q squared, sorry, this is a squared over r and cos of theta plus the extra terms. Now, what kind of terms we have dropped here? The terms that we have dropped here are actually contributing very less to this relation, because those are the terms in which q over r to the power n, and when this n was greater than 2, because here if you look, here is q over r2, here is q over r2. So up to r2 we have kept the terms, and the terms which were greater than r to the power 2 we have dropped those terms because their contribution is negligible.